Right when I was in the middle of explaining that, the video stopped because my computer ran out of memory and it just had to stop recording. So I have worked with that now. Hopefully, it won't happen again. Let's pick it up where we left off. The standard form of the hyperbola. So if it opens right and left, like the drawing has, we have one opening right, one opening left, then it's going to take this form, x minus h squared over a squared, minus this time y minus k squared over b squared, and it equals 1. So just one alteration to the equations for the ellipse. We make it a minus instead of a plus for the hyperbola. Here, keep in mind the values of a and b. So here, a and b, the relationship doesn't matter. So we're not saying for the case of the hyperbola, a is not necessarily the bigger number. What's important is a goes with x, b goes with y. So here a goes horizontally, but b might be the bigger of the two numbers, right? That would just mean, it's wider. But what makes it right and left is that the x comes in the first position, we subtract the y. So the horizontal comes first, so we know it opens horizontally. That's the way most people think of it. Okay, the other one, if it opens up and down, well, then the y comes first because it will open vertically. Still put the a with that one. So the a is always going to come first, although it's not necessarily the bigger number. Hopefully that's not too confusing. So y minus k squared over a squared minus x minus h squared over b squared equals 1. Again, the a we always think of being the distance to the vertex. So if it's opening up and down, we need that to be with the y. What's the relationship? Oh, my mistake. I'll give you the relationship between a, b, and c on the next page. The asymptotes, the slopes. So you might be asked to find the equations of the asymptotes. The asymptotes have slopes. Well, if it's the opens right and left style, then they have slopes plus and minus b over a. Why is that? Well, starting from the center, you go rise and run, right? Up b over a, 1, or down b over, if it's the up and down style, then we're going to take the reciprocal. It's a over b because the rise would be a and b would be the run. All right. Let's talk about the eccentricity of a hyperbola. Oh, looks like I'm not going to mention the connection between A, B, and C on the next page. I left it out completely. My mistake. I guess I ran out of space and I just forgot about it. The connection between A, B, and C, C squared equals A squared plus B squared. So now C is the longer, it's bigger than A. So if you were to think of, maybe that right triangle there, A, B, turns out that distance C would be the same as that hypotenuse. I think my drawing's a bit off. My C should probably be a little closer in to be that same length. But kind of think of, kind of swinging that down. That should be where C is. There it is right there. Okay. Eccentricity of the hyperbola. We just take that formula for the ellipse and take the reciprocal. Here, E is defined as C over A. Well, that's the same. That's actually the same equation, isn't it? It's still C over A. Oh, okay. My mistake. We don't take the reciprocal. Just turns out that C is the bigger number between the two. C is larger than A is now. It's still the same equation. The eccentricity equals C over A. Okay. Now, E is going to be something bigger than 1. And the higher it gets, the more elongated, or maybe like the narrower, those two sides of the hyperbola are. All right. Let's check out an example. Still a pre-calc example. I'm going to save the calculus examples for you guys in the homework. since those things are going to be a little bit more familiar, and not, they're going to build on concepts we've already been working with. These pre-calc examples are actually probably the more foreign at this point. So, example, consider a hyperbola with vertices -1, 0 and 7, 0, and with foci -2, 0 and 8, 0. Part A. What's the equation of the hyperbola in standard form? So this is more similar to that very first example we did with the parabola. We're given some information. What's the equation of the hyperbola? Okay. Well, I think a great idea is to give yourself just a rough sketch of the graph. So let's graph all 4 of these points, knowing our vertices, knowing which are the foci. So I did that here. I think we can probably fit just about everything. Okay, so we've got -1, 0. That's the first vertex. 7, 0. Other vertex. Foci -2, 0 and 8, 0. So we can tell if these are the vertices and these are the foci, this is going to open right and left. Like so. Now that's going to be helpful. So we know this is what we're working with. X minus h squared over a squared minus y minus k squared over b squared equals 1. Ignore what's over here on this side for the moment. We'll come back to that later. Okay, I know this. Let's just try and identify what we can. Can we identify the center? Okay, well the center is going to fall right there in the middle. It's going to be on the x-axis. Well, what does that mean for k? K is going to equal 0, right? The y-coordinate of the vertex, or of the center, excuse me. Maybe a bit more interesting, what is h? What number is right in between them? Well, one way to do it, you might be able to just eyeball it, and that would be fine without any work. Or you might take the average of the vertices, 7, -1. You could take the average of the foci coordinates there. You'll get 3. So right there in the middle, h equals 3. Hey, once we have h, important to start with that, because then what is a and what is c? We can get those. And let's just show those. Well, the distance from the center to the vertices, that's a. We always think of it as positive. It's a distance, 4. C, the distance to the foci, well, that's 5. Like, all right, I know HK, I know A, but C wasn't a part of this. True, but we need C in order to find out what B equals, and that's where this side comes in. We'll use C squared equals A squared plus B squared, and, well, we've got that 3, 4, 5 Pythagorean relationship going on. So 5 squared equals 4 squared plus b squared. That's 25 and 16. Subtract, and b eventually equals 3. And we can answer this first part of the question right there. H is 3. K was 0, so we just have y squared. A was 4. B was 3. It's opening right and left, so there you have it. Let's check out part B of this question. What are the equations of the asymptotes? Well, if you're opening right and left, then remember the slopes of those asymptotes are plus and minus b over a. And you always pass through the center of your hyperbola. So that's going to be helpful. So what does that mean for us? Well, if we think about the center, think about a and b. The slopes will be plus and minus 3 over 4. and it'll pass through, both of them will pass through the point 3, 0. So we can pretty quickly get the formulas. We can get the equations for both of those asymptotes using the point slope form, and I'll just show you both of them. I got them side by side. For the first one with positive 3 over 4 slope, y minus 0, 3 over 4 times x minus 3, point slope form, right? Well, since that's a 0, there's not a whole lot to do. Y equals 3/4 x minus 9/4. And over here, same idea, but now with the negative 3 over 4 slope. So when you multiply that out, negative 3 over 4x plus 9 over 4 is the other asymptote. That's it. That's my last example. Go check out the homework. You'll see problems obviously similar to ones we've done. And you'll see some calculus ones too. Good luck.